Hello everyone. In this video, we are going to learn how to fit a GARCH model for a given dataset. So I will go through the question. So we are having a question here. Make use of RStudio and fit the GARCH model. Here it is. GARCH model means simple standard GARCH, that is GARCH 11 model for the following particulars. The stock symbol is mrf.ns from 2024 January 1st to 2024. I will make small correction here. I will take 5 years data 2020 to 2024. So we'll see how this we can fit the GARCH model in using RStudio. So we'll go back to the RStudio. For fitting the GARCH model, we have to extract the data. So first one will be QuantMod package we are going to use for extracting the data. Then we are going to check the stationarity of the time series data. So for that we are using T series package. Then we are going to fit the GARCH model. For that we are using RU GARCH model. So if you're not having these three packages, first you install the packages, go to packages. In install you are getting pop-up window there. Yeah, here you can type and type that packages and you can install it. I have already installed, so I'm not again going to install. So after importing the library, so after writing this script, I will run the code, control enter. Now I have imported the library. Now, how to extract the data from Yahoo Finance? So first I have to mention which stock data you have to extract. That symbol equal to, you can give any name here, x equal to y equal to anything you can mention. So to be for my I will be writing symbol here. So symbol equal to mrf.ns from which date to which date. So equal start date equal to, this will be in year, month and date format. So 2020 January 1st. The end date equal to 2024 December. Then after specifying these three variable, I am going to use get symbols. Get symbols. In this four elements, we have to mention four parameters. First one will be first element, that is symbol, comma. Second element is from which source you are taking, you want to extract the data. So that is source equal to Yahoo. No need of mentioning Yahoo Finance. Then third one will be from which date to which date. So from will be our start date variable. Then two will be our end date variable. Instead of mentioning these three elements, you can directly mention in this code also. So in that way, you can reduce the number of lines in the code Rscript. But for a clarity, it is better to separate them and in case if there is any mistake in the code, you can easily identify, you can easily correct them instead of going with the 4 to 5 lines of code. So this is what I'm preferring. So we'll run these four codes. Okay, end date. Okay, here I didn't mention end date. We'll run the code. Yes, in the global environment, we got mrf.ns for 5 years. 4 years, not 5 years. 4 years data we have extracted. But in this, I want only closing price. So again, after I will be writing another code. I will define the variable as mrf equal to closing. I want only closing of that particular data, closing column, closing price column. So C capital, L small case, closing of mrf dot ns. I will hit control enter. So I have extracted the, now only closing prices are there. Then I will this also okay. Till here we have used first package QuantMod. Then anymore I will be using T series package functions. So for that I'm going to plot the time series, means plot the variable whatever closing price we have extracted. Yes, there is a trend. So you can see there is a trend here. Then we will calculate the log returns to get the stationary data. So first I will define new variable, that is return of MRF equal to na.omit. While calculating log returns, if you get any NA values, you have to omit it. Otherwise, the variable will not be defined. There will be error in the coding, error in the output. So better while defining the variable only you use this na.omit. Log returns for, code is diff log of MRF, that is closing price. So what we are doing is find the returns of closing price of MRF log returns, that is about this code. Then if you find any NA values in that, exclude them, omit them. That is the actual meaning of this code. So I will run the code. So we got new variable here, RMRF, log returns are calculated. Now again plot the variable, plot.ts, whatever RMRF we have calculated, we'll plot them. So now you can see, so these are the 4 years log returns. So you can see the clustering in between, high variable followed by high variation, again low variation followed by lower volatility, again the clustering you can see here. So but overall it's hovering around 0. So overall variation, average variation we can see here 0. So it's an indication that data is stationary. To prove this one, we are using ADF test. So ADF.test, another function from T-series package, we are using ADF.test of return log returns, that is RMRF. So in the console, you can see the output here. P value is lesser than 0.01. That means there is no unit root or data is stationary. Now this data is eligible for fitting the GARCH model. So this is the T-series package functionality we are using. This is for quant mode functionality. I will just write it as hashtag quant mode package I am using. Here this one for T-series. Okay. Then next one I will be using row GARCH, that is univariate GARCH. For this, you have to specify the model, you have to fit the model. So specification, I will mention MRF underscore GARCH. You can just mention MRF GARCH also. I will mention spec also, means specification it is. So MRF GARCH spec equal to U GARCH spec. In that two elements we have to mention. In suggestion also you can see variance.model and mean.model. So variance dot model equal to list of, I am fitting GARCH, standard GARCH, that is GARCH 11 model. So model name will be yes GARCH, comma GARCH order will be, GARCH are always in this C of bracket 1 comma 1 comma. Next one is mean dot model, mean equation parameters. In this, we are not mentioning any model name. We are just mentioning ARMA order equal to C of 1 comma 1. We are using one lag of ARMA model here. So this is my specification. We'll run the code. So my GARCH spec is properly run. I have already specified the GARCH model. Now, in this empty GARCH model, I have to feed the data. I have to feed it with returns of my MRF stocks. So I have to fit the GARCH model. That is the literal meaning of this MRF underscore GARCH underscore fit equal to ugarch fit of. So there are two elements I'm specifying. One is specification, that is a model specification, and data for that model. So model specification is my previous code, that is mrf garch spec. This is my variable where I have defined the model. So you refer this model for fitting the garch model, and I am also telling that code in the Rscript that take rmrf variable, sorry, rmrf variable for this fitting the garch model. So I will run this code. So now garch fit variable is defined. To check the output, I will take only, you can click here in data environment, you can get the variables here, all the coefficient, everything you can get. But again, it is better you go with, if you want to check it in console, I will just mention the entire fit variable name. I will run the code so you can see the variable here. So this is my GARCH model fit. Yes, GARCH1 RFIMA, that is fractionally integrated moving averages, that is 1 comma 1, because I have mentioned ARMA1, AR1 and MA1 component, and rest of the things are there. So I will take this one. This is my final output, optimal parameters. I will put it in my new document. Okay, so give me some time, so I will put it in proper format. Okay, so this is my GARCH11 output. Now I have to explain all these 6 parameters. So first 3 elements are coming under mean equation. Next 3 elements are coming under variance equation. So this is mean equation element, variance equation elements. So if you go with the p-values here, they are not at all statistically significant. We are accepting null hypothesis here because their p-values are more than 0.05. When it comes to variance equation, all are statistically significant. So how to analyze this? So here first one we will mention 0.076. I'll put all these values here. Okay. So this is a constant term of mean equation indicating change or variation in returns when AR1 and MA1, that is, since we have taken AR1 MA1 in ARMA order 1 we have mentioned, when these values are 0, when the AR1 are 0, when the variations are 0, indicating the change in the log return, since we have taken log returns in as the variable of MRF. Okay, so this is the explanation for this. Now next one here, this one is the impact of AR1 indicates the impact of previous day, that is lag 1, previous day log returns on current day. Impact, the proportionate impact, we can say around -7%. So we can say 7% negative impact of previous log returns on current day log returns. So this is my constant. Now this is my AR1 term. Next one is MA1. So while in writing analysis, you can mention this what it means actually. MA1 is moving average one. Normally it talks about the residuals. Indicate the previous day log return. Instead of that, residuals. Residuals on current day. You can see positive impact 3% positive impact of previous day. Instead of log return, you can mention residuals on current day log returns. But since there is no, they are not statistically significant, this technically doesn't make sense. They are not having any impact because the p-value is more than 0.05. But if you get lesser than 0.05, this is the way you can analyze those terms. Next one, omega, that is again constant term in, I will take this one again explanation. This is a constant term of variance equation indicating change in volatility or variance of MRF when alpha 1 and beta 1, alpha 1 and beta 1 are 0. Means when these values are 0, when there is no impact of our alpha and beta term, still there will be a volatility you can observe in the MRF log returns, that is indicated by omega. Okay, and it is statistically significant. Next one, alpha 1. This is the arch term and this is the GARCH term. Arch term tells about yesterday's shocks. It indicates impact. It is the arch term. You can mention like this. It is the arch term, indicates the impact of past shocks on volatility. Impact of past terms. Yeah, impact of past shocks on current volatility, today's volatility. So around 28% impact, 28% impact. That means yeah, 28% positive impact, since it is plus 0.28, positive impact is observed. Then again, I will copy this statement again, I will paste it here. This is the GARCH term, indicate persistence, impact of past shocks, we can say past volatility. It is a persistence effect. So you can say GARCH term, it represents, you can write persistence volatility. It indicates the impact of past volatility and current volatility. 49% positive impact is observed. So in this way you can write the explanation for these 6 terms. Next one, the mean equation. And variance equation. So I will just take the previous one. Yeah. So I will write it here, mean equation. First I will write all these three values. I'll copy it. I'll paste it here as values. Then I will bring them into the first line. Same way I will do it for next three. For variance equation, since all are positive, I will use it plus symbol. Now, this is a constant term, and this is my AR 1 lakh and AR MA with 1 lakh. This is again constant term omega, and this is my arch parameter, and this is my GARCH parameter. So this one I am referring as RT, that is log returns. Since it is a mean equation, I will go to equation. I will use this one, returns of T equal to, and this is previous day return. So my AR1 T minus 1, and again this is my previous day error term. So this I will go to equation. I will change the symbol here. We are having error term, this one, T minus 1. Since previous day it's past shocks, we have mentioned residuals of previous day, so ET minus 1. So this is my mean equation. Then variance equation, normally we are representing in here I have mentioned HT, but you can mention summation sigma square here instead of HT. Go to insert, I will use this, and for this I will use sigma. Okay. Variance equation, but again for the period T. This will be T and this will be variance. Yeah. Sorry for this. Okay. Sigma T equal to 0.063, and this is again this one, past shocks. So residual square cities, you can see residual squares. So I will be having insert equation, new equation. Here I am having this one. This one will be my error term E, and this should be squared, but of previous day, so T minus 1. This one again same, control C, control V, but previous day shocks minus 1. So HT minus 1, I have mentioned this one. So this is my variance equation. So this is how you can write the analysis of GARCH output. So I will be putting this in my description. You can get it from there also. I will paste the link as well of the Rscript. I will use it. Uh, yeah, I think I have this. Okay, this is my Rscript. So you can use this when I have spelling error I didn't see. Okay, this is my Rscript for GARCH 11 model, and this is the output analysis. Okay, you can add this explanation as well. Volatility clustering. I will just change the values here. 0.282998 and beta 1 will be 0.493803, and it's around, we can see here, not close to 1. This one, the previous, the example you take around, I think 60 77. Let me just take the calculator here, paste it, this one. Yes. So we got 7760, but pretty good number. You can say more than 75%, demonstrating the, instead of that, higher persistence. We cannot say strong persistence. Higher persistence of volatility. Higher volatility tends to higher volatility. Lower volatility tends to persist, which is a key characteristics. One more we didn't do in this, that is the main element of GARCH output, that is news impact curve. So again, I will go back to coding. So the news impact, I will mention MRF underscore news impact equal to news impact of my GARCH fit MRF. So I have defined the news impact. Now I have to plot them. Let me just take the code from my manual. So this is my code. So plot news impact of ZX, plot news impact of ZY. I think I mentioned news underscore impact. Yeah, I have mentioned. Yeah, means X variable and Y variable, Y axis, X axis. Then X label, we are going to mention, it is represented by shocks, that's previous day residuals, shocks, squared residuals. It is conditional volatility, that is again your alpha and beta terms here. And the title of that plot will be, here instead of this, I will mention MRF GARCH model. Yeah, news impact curve for MRF GARCH model. So we'll run the code. So as you can see here, a necklace type where a plot is visible here. So how to interpret this? If you see, then these are the shocks, the negative shocks and positive shocks. And this is the impact of negative shock, that is conditional volatility, impact on volatility. So that is why conditional volatility based on the shocks. So here the negative shocks are having, again you can see 0.025, around 2%. Same way the positive shocks also having similar impact. The proportion, the impact of negative shocks and positive shocks are same. Impact of negative shocks and positive shocks are same. Normally it won't happen. If you see in real-time stock market, the negative shocks, you can say around 10% dip most of the time. If it is a long-term one, around 10 to 15% dip you can find in the stock prices, the volatility. But at the same time, the proportion of positive shock, the positive news, it may not be the same. That's why that is a limitation here. The GARCH 11 model, it takes equally. So negative shocks and positive shocks, the impacts are same. So this is how, through news impact curve, we can analyze this GARCH model. So you can, I will put this code here, this one. I'll put it in this one, news impact. So this is about the news impact curve, again from GARCH package. I will take this one, copy image. I will go to my Word document. I will paste it here. Okay. The impact analysis will be same. Whatever I have written, I will take the same thing for time being. Only the stocks are different. No matter which stock you take, the news impact curve in GARCH 11 model will be similar. So the analysis will be like this. The news impact curve for a MRF GARCH model illustrates how shocks represented by standardized residuals in x-axis influence conditional volatility, and that's what I have mentioned. The impact of shocks on the conditional volatility. The symmetric U-shaped curve. So this is very important to mention in the analysis. The symmetric U-shaped curve you can find only in GARCH 11 model. The curve suggests that both positive and negative shocks have equal effect on volatility. That is also important term in your analysis. You have to mention. So this one, the symmetric U-shaped curve that you should get while running this code, and it should have the equal effect. Indicating no asymmetric response means, or leverage effect means, negative shocks and positive shocks both have same impact on the volatility. This is the typical GARCH model, the standard GARCH model, where volatility rises similarly in response to positive and negative news. So this is the analysis. So this is how you can analyze, interpret GARCH 11 model. This is my Rscript and this is the output analysis. I will paste this link in the video description. Thanks for watching.